Today is February 5th, 2023. This is my 218th episode for C++ 17 2023 Coda SQL OpenGL OpenCL DBB Balkan. This is my 48th episode for vector calculus, 10th episode for surface integral. In this episode, we will discuss explicit function, rectangular to polar integration. I will update my C++ library extension in this video. After filming video, you can double-click this link to download updated C++ library extensions. Without further ado, let's get started. Open up Visual Studio Code. CPP 17 2023 parallel. Select empty space. Click this button. 218. Implicit. Click this button. Implicit.cpp. Hit enter. Ctrl B. I will close this document. I will copy and paste this text. After filming this video, you have to Ctrl click this link and download updated C++ library extension. I made simple mistake in two of my previous videos, episode 216, episode 217. I made a simple mistake and I will fix that mistake in this episode. I will drag and drop Calculus by James Stewart. This is Calculus by James Stewart. In this book, page 1185, you can find formula for surface integral. I will not explain the theory in this book. I assume you have read the theory in this part of the book. Instead, we will solve example 3. Evaluate double integral C ds, where S is the surface whose side S1 are given by the cylinder x squared plus y squared equals 1, whose bottom S2 is the disk x squared plus y squared less than 1 in the plane g equals 0, and whose top S3 is the part of the plane c equals 1 plus x that lies above S2. In figure 3, this is surface S1, this lateral surface of a cylinder. This is S3, the top of this cylinder. We will evaluate surface S1, the lateral surface, first. Now, I will arrange like this. Here, void solve surface integral. Example 3 S1. Int main, copy the function name, paste it in function main. In this figure, we are integrating S1, the lateral surface of a cylinder. Cylinder can be parametrized like this. Auto R CNA create BCTR3D. This is function. We take two parameters. Auto theta. Theta represent angle from x-axis in the counterclockwise direction on xy plane. Auto z is z coordinates in this figure. Return SED cosine theta. Because our circle is unit circle, we don't need to multiply 1 here. Because it is unit circle, copy, paste, SED sine. In case of z, we can simply put z. So, vector r parameterize this cylinder for surface S1. Now auto S. From R we use surface integral. Y is squiggle. CNA I should remove trailing comma. We pass from the example 3, we have to pass G. G is the density. So we can simply pass this function. Copy, paste. This represents density. I will give line break. Density for G. This function is this G. Now SED make tuple. We pass the interval for theta because we are making a full circle. It should be 0.02 times pi. Copy paste. Now the range of G runs from 0. It is a function 1 plus x. So it should be function or theta. It should be function return 1 plus x. G equals 1 plus x, but our parameter is theta g. So we have to do SED cosine theta. I will make it bigger. Then this is for theta limits. This is for z limits. So dz dt. But I haven't defined dz dt. I haven't defined it. We can define like this. Context per or dz dt cpt sequence. We have to pass some value. Now the position in this parameter list. Z has position index 1. So it can be 1. 1 represent 0, 1. D, T. T for theta. It represents 0. We have to Sapiensize like this. 0, 1. Or reverse. Scroll down. We defined dz dt. It should work, but it doesn't work because I made a mistake in our previous episode here. Because I made a mistake in this video, it does not work. To make it work, we have to fix. Open CPG calculus. Control F. Surface integral. Here, I made a mistake here. It should be callable or floating point C. I have to fix like this. Also scroll down. It should also be fixed callable or floating point C like this. I will make more changes. Here too, also here, also here. I made a mistake. Here. With this, it should be enabled. Auto answer in this book, the answer is 3 pi over 2. 3 times pi over 2. CNN print answer. S answer. Now open up your command prompt. cd 218 implicit clang sed c++20 implicit.cpp ltbb12 oc.exe, hit enter. clsc. So we solved surface S1 like this. Very simple. Now scroll up. We will solve surface top of this cylinder, surface S3. Void solve surface integral. Example 3 S3. Copy this function, Control N, paste it here. I will disable it. We define z equal 1 plus x. Or z, we take two parameters, or x, or y, don't miss semicolon, return z equals 1 plus x, 1 plus x. Now, or dz over dx. We capture z or x or y, don't miss semicolon. We are differentiating z with respect to x. We are performing partial derivative. Return CNA partial derivative dx1. It means we are differentiating with respect to x. First order derivative. We pass g x y. Copy, paste. Now we differentiate with respect to y. So it should be dy. Scroll down. I will give you explanations. So dz dx represent this part. dz dy represent this part. Now we compute this part like this. Or dA rectangular. We capture dz dx, dz dy or x or y. We are learning functional programming. Now here or gx dz dx, we pass x y, copy, paste gy dz dy. So we evaluated round z over round x, round z over round y here. Then return SED SQRT 1 plus gx times gx plus gy times gy. This represents dA in rectangular coordinate system. Sadly, this is not good enough. I missed this part because we have to put z. This z is 1 plus x. This z is 1 plus x. So I missed here 1 plus x times. I fixed this part. So 1 plus x represent 1 plus x. STD square root. This part represent this part. Now we have to convert to polar coordinate system like this. Or dA polar. We capture rectangular dA. Then or radius rho theta. We are converting from rectangular coordinate to polar coordinate like this. Rho x equals radius times SED cosine theta. Copy, paste. Y equals radius times sine theta. So we have xy. Then return. We can use dA on rectangular coordinate by passing x, y. So we created dA polar. dA polar represent this part. But we missed one thing. This part represent this part. We missed r, radius. This r second radius times. Don't miss this part. This radius represent this radius r. With this, we do integration. Rho s. It is S3. Sine integral. We pass dA polar. Then SED make tuple. In our case, theta runs from 0 to pi because here theta, the angle from x-axis, makes one full circle. So from 0.0 2 times pi. This is theta limits. Now SED make tuple. Our circle radius. This radius is bounded by 1. So radius r should run from 0 up to 1. This circle. So radius should be 0.0, 1.0. This is radius limits. Then we specify integration order. The last is radius limits. So dr, then dt. With this, let's see, it is defined like this. Then rho answer. In this book, the answer is square root 2 pi. SQRT square root 2 pi. CNA print answer. S3 answer. So we created this function. We copy and pasted the function name here. Now we rebuild. CLSC. Our solution matches exactly with the algebraic answer in this book. Please understand, in this example, we started on rectangular coordinates, then we converted to polar coordinates, then we performed integration. In the same manner, we started on rectangular coordinates, then we converted from rectangular coordinates to polar coordinates. At this step, you should not miss r. This r. This r is important. Then we integrated on polar coordinate system. I assume you have read theory in this book, how this formula was derived. If you understand and practice a little bit, you can proficiently use this formula. In future episodes, I will turn this process into a complete library function.